Directional derivative. Okay, what's a good formula for the directional derivative? Well, here's the symbolism. I like del f dot u. That's a nice way to write it. Del f dot u. So once again, then, what's del f going to be? Actually, let's find the partials first. F sub x, we're going to need the partials for del f. So what are the partials here? Okay, so everybody, I want everybody to focus here. What's the partial on this? It's x times y to the 1/2 power, right?
Negative y over 2 root xy.
Okay, but is that how you think of it when you take the derivative? I think of it as 1/2 x times y to the negative 1/2 at first, at least, right? And then times what? What's the derivative of the inner function with respect to x? Times y. So I mean, I would think most people would think of it like that, and then you gave me like the final answer, right? So what did you give me for your final answer?
It's negative y over 2 root xy.
Would it be negative y? So wouldn't it be y on top, just this y, right?
Oh, yeah.
Over 2 square root of x times y? Does everybody believe that? Okay. And then okay, now can we use a little symmetry here to get f sub y? What would that be?
X on the top.
Same thing except x on the top. So that's kind of nice. And then, so del f would be the vector of partials y over 2 square root of xy, x over 2 square root of xy. But where do we want del f at? 4, 9. So what do we get when we plug in 4 and 9 here? So we'll start with 9 on top, right? That y value right there. 9 over 2 times 6, right? Square root of 36. Square root of x times y, 4 times 9 is 36. So 2 times 6. Would everybody buy that? I'll simplify that in the next step. And then for this guy, what do we get? What do we get on top? 4. And then, of course, we'll get the 12 on the bottom. And then, not that you guys were wrong, it's just nice to see steps, isn't it? So 9/12, what does that reduce to? 3/4. And 4/12, as you already said, 1/3. Okay. So there's your del f. And then u. Oh, okay. Well, how do we find u? Well, I mean, that's a start, but will that be u? Will that be the u we use? No. So, okay, so what's PQ? Tip minus tail. 6 minus 4 would be 2, negative 4, and then that is not u. U has to be a unit vector. So magnitude PQ would equal the square root of 4 plus 16, square root 20, or I suppose if you like 2 rad 5. You don't like that? I don't like that. So what's u going to be then? It's going to be 1 over 2 radical 5 times 2 negative 4. Would you buy that? And then it might be nice to go ahead and scalar multiply out the 1 over 2 rad 5. So that would get you just 1 over rad 5, because the 2's will cancel. Does everybody see that? And then what? Negative 2 over radical 5. Okay? And so, finally, what's the directional derivative evaluated at, what was it? Find the direction at the 0.49. in the direction of 6, 5, so at 4, 9, right? Well, that's going to be this guy dotted with this guy. So that's going to be, I'll just write it out, 3/4, 1/3, dotted with 1 over root 5, negative 2 over root 5. Okay, what does that turn out to be? So multiply corresponding components, and what do we get? 3 over 4 root 5 minus 2 over 3 root 5. Does everybody buy that? Now, you could combine those in one by getting a common denominator. I'm going to let you guys take it from here. It's just arithmetic, algebra / arithmetic.